Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Images of two iconic planetary nebulae taken by the Hubble Space Telescope are revealing new information about how they develop their dramatic features. Researchers from Rochester Institute of Technology and Green Bank Observatory presented new findings about the Butterfly Nebula, NGC 6302, and the Jewel Bug Nebula, NGC 7027, at the 237th meeting of the American Astronomical Society on Friday, January 15. Hubble's Wide Field Camera 3 observed the nebulae in 2019 and early 2020 using its full, panchromatic capabilities, and the astronomers involved in the project have been using emission line images from near-ultraviolet to near-infrared light to learn more about their properties. The studies were first of their kind panchromatic imaging surveys designed to understand the formation process and test models of binary star-driven planetary nebula shaping. "We're dissecting them," said Joel Kastner, a professor in Rochester F. Carlson Center for Imaging Science and School of Physics and Astronomy. "We're able to see the effect of the dying central star in how it's shedding and shredding its ejected material. We're able to see that material that the central star has tossed away as being dominated by ionized gas, where it's dominated by cooler dust, and even how the hot gas is being ionized, whether by the star's UV or by collisions caused by its present, fast winds." Kastner said analysis of the new HST. Surprisingly, they found that while astronomers previously believed they had located the nebula's central star, it was actually a star not associated with the nebula that is much closer to Earth than the nebula. Kastner said he hopes that future studies with the James Webb Space Telescope could help locate the actual central star. The team's ongoing analysis of the Jewel Bug Nebula is built on a 25-year baseline of measurements dating back to early Hubble imaging. Paula Moraga Baez, an astrophysical sciences and technology Ph.D. student from DeKalb, Ill., called the nebula remarkable for its unusual juxtaposition of circularly symmetric, axisymmetric, and point-symmetric bipolar structures. Moraga noted, "The nebula also retains large masses of molecules. The combined observations from telescopes at other wavelengths, like Hubble, and bright molecules CO+ and HCO+ from NOEMA indicate how different regions of NGC 7027 are affected by the irradiation of its central star. We're very excited about these findings," said Bublitz. "We had hoped to find structure that clearly showed CO+ and HCO+ spatially coincident or entirely in distinctive regions, which we did. This is the first map of NGC 7027, or any planetary nebula, in the molecule CO+, and only the second CO+ map of any astronomical source." In addition to Kastner, Moraga, and Bublitz, the research team involved in the HST imaging work includes Rodolfo Montes Jr. 10 Ph.D. Astrophysical Sciences A. Bublitz international team of collaborators on radio-molecular line imaging of NGC 7027 includes Kastner, Montes Jr., and astrophysicists from Spain, France, and Brazil. Story source. Materials provided by Rochester Institute of Technology. Original written by Luke Auburn. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.